All right, video number 2. Now we're going to be, as the title says, hey, we've already stepped it up here. We have a title to start off the show, Balancing Equations. It's the law. All right, so we said in the previous video, the first one, counting atoms, that balancing equations is the second most important skill right now in our course. The first one being names and formulas, and now balancing equations. The reason I wrote it's the law, it's because it's the law of conservation of matter. Right? The law of conservation of matter, right? If we think about what the word conserve means to keep. So when we talk about the law of conservation of matter, it means to keep the matter. We don't lose any, we don't gain any. So basically, if we look at reaction, we have reactants going in, and they form products that come out of the reaction. This basically means that if I have, like I said earlier, 5 carbons going in, I have to have 5 carbons come out. Right? If I have 6 hydrogens going in as various parts of my reactants, those 6 hydrogens have to end up somewhere in my products. All right? It's also known as the law of conservation of mass. 5 carbons at 12 atomic mass units apiece equals 60 atomic mass units. 60 go in as 5 carbons are here. 5 carbons come out, maybe attached to different things, but it still equals 5 times 12, which is the 60. 6 hydrogens at 1 apiece is 6 atomic mass units going in. 6 hydrogens come out, 6 atomic mass units come out. So the matter has a certain mass, and if we keep the matter, we keep the mass. So we quite often hear in chemistry the law of conservation of matter and the law of conservation of mass used interchangeably, and they basically are. All right, so let's do some examples. I've got some great examples here. So let's do that. Our first example, we'll do a nice easy one. What we'll do is we'll take nitrogen gas and hydrogen gas, and we'll combine those together to make ammonia. All right? So again, following the law of conservation of matter, here's a good skeleton equation. Nitrogen gas is N2, hydrogen gas is H2, and ammonia is NH3. So my formulas are correct. That's the number one skill. If I don't get the formulas right, none of this makes any sense whatsoever. So I got good formulas here. Now, what I have to do, I have to start counting. So what I always do is I start with this first element, nitrogen right here. And it says here I have 2 nitrogens going in. These are my reactants. I treat this yield sign like an equal sign. Whatever's on this side of the arrow has to equal whatever's on this side over here. So I have 2 nitrogens going in. Over here, I don't look at this 3. This 3 belongs to the H. There's a little 1 here. All right, I'll pencil it in. We normally wouldn't, but for the sake of learning, we will. So I've got 2 N's going in, and that's supposed to equal 2 N's coming out, you'd think, but we only have 1. So what we do is we use numbers called coefficients. I cannot change these little numbers. If I change them, I'm dead. I start changing things into other things that shouldn't be there. And that can have dire consequences. Like the joke that I tell you. 2 guys go into a bar. The first guy orders an H2O. The second guy says, I'll have an H2O too. The second guy dies. Anyway, you get the importance of formulas. So if it's ammonia, it's NH3. I can't do this. I'll see people do that. That's crazy. And now it's no longer ammonia. So we can't touch the subscripts. All right? One of the rules of Chemistry Fight Club is if you touch the subscripts, I'll kill you. You probably end up killing yourself because you'll blow yourself up in the lab sooner or later. It'll catch up with you. So that's a little visible 1. I'm writing it in, but it's a little invisible 1 for now. 2 go in, 2 have to come out. So what I do add is a big number in front. This large 2 is a coefficient. These are subscripts. The 2 here, the 2 here, and the 3 here are subscripts. This is a coefficient. That's what I got to add. I can mess around with coefficients all day. It doesn't touch the formula. So now 2 n's are going in and 2 n's are coming out. I'm going to get rid of this now because we know what that is. Now, hydrogens. All right, I finished my first element. Go to the next one. Hydrogen. I've got 2 going in and I've got 3 here, but this 2, as per the earlier video on counting atoms, applies to this as well. So 2 times 3 is 6. That means I have to make this 6. And this is something we see quite often. In 2 of one thing, 3 of the same thing on the other side. Sometimes the 2 is here and the 3 here like it is here. Sometimes it's 3 and 2. But whenever we get this, the 2 and the 3, we make them into 6. This one's already 6. 2 times 3, that's 6. So to turn this into 6, we put a 3 there. And again, every time I put something in here, I go back to the beginning and I check it. 2 nitrogens, 2 nitrogens. 2 times 3 is 6 hydrogens. 3 times 2 is 6 hydrogens. So this one's completed. This one's good. No problems here. Now we'll do another one that has a little bit more to it. All right? So let's take a look at, we'll do Al2 SO4 3 plus K2O yields Al2O3 plus we would have K2SO4. All right? So when we look at this one, all right, we've got a polyatomic in here. This sulfate is a polyatomic. Now, I know we start with the first element, which would be aluminum. We'll balance that off, and then we'll go through the rest of it. But with the polyatomics, what I try to do is if I see SO4 going in and SO4 coming out, I try to keep them. I don't break them down to the sulfur and oxygen. I see if this cluster will cancel out this cluster somehow and balance it out. You'll see what we're talking about in a second. So I've got 2 aluminums going in, 2 aluminums coming out. Remember, this is like an equal sign. 2 aluminums in, 2 aluminums out. Aluminum's already good. No problems. Now, sulfate. If I underline what sulfate is, which is that, I have 3 of these sulfate clusters. So I go over here and I have only 1, right? Only 1 of these sulfate clusters. So I've got to put a 3 in there. And again, I put a big 3 in front. 3 sulfates, 3 sulfates. All right? So every time I put a new coefficient in, I start at the beginning. 2 aluminums, 2 aluminums, 3 sulfate clusters, 3 sulfate clusters. All right? The 4 is part of the sulfate. I don't consider that right now. Next element, K, potassium. I have 2 going in, and I had 2 coming out, but this 3 applies to it. So I have 3 times 2, which is 6. So I have to make this into 6. 3 times 2 is now 6. I added a coefficient. I got to go back to the beginning. 2 Als, 2 Als, 3 sulfate clusters, 3 sulfate clusters. 3 times 2 is 6 potassium. 3 times 2 is 6 potassium. And 3 O's and 3 O's. The O's are already fixed. By adding this 3, it fixed that. So there's that one balanced perfectly for us. I'm going to erase this very quickly, and we'll do a couple more. So the next one is a combustion reaction. So what I'm going to start with is C3H8. This is propane, like in your barbecue tank, right? When you go camping, or maybe you have a barbecue in your barn or your backyard. I just said barn. There's my Nova Scotia coming through. Anyway, it's a combustion reaction. So we're completely combusting the propane. And there we go. So we have propane combining rapidly with oxygen forming carbon dioxide and water. I'm going to put this little equal sign there. Now, you don't write the equal sign when you're doing it, but we're just saying this side has to equal this side. So as we go through, right, 3 C's, only 1 C here. That 2 belongs to the oxygen, so only 1 C there. So I'll put a 3 here. 3 C's, 3 C's. 8 H's, 8 hydrogens. Here I've only got 2. So 4 times 2 is 8. 8 going in, 8 coming out. Everything's great. Our last thing, I've got 2 oxygens. Here I've got 2 sources of oxygen. I have oxygen here and oxygen here. So I have to actually add these 2 oxygens, because it says add right here. Whatever I have here is added to this. So 3 times 2 is 6 oxygens there. And 4 times 1 is 4 oxygens there. So my total oxygens is 10 oxygens going in. I have to make this 10. 2 times, well, 5. And that'll give me the 10. So if I look, 3 C's, 3 C's. 8 H's, 2 times 4, 8 H's. 10 oxygens, 3 times 2 is 6, plus another 4, and we've got our 10 oxygens. So that one is done. Now, I am going to show you another combustion reaction that kind of does a weird thing. All right? So, we'll do this. C. 4H10 plus O2 yields CO2 and H2O. Propane was the last one. This is butane, like in a lighter that you'd get at the Dollarama, one of the best stores in the world. But butane, so the fuel in lighters. Anyway, I start going through it the same way. So if we look, start with my first element, 4 carbons. I have only 1 carbon here. Technically, there's a little 1 there. So I'll go 4 there. And I go, okay, 4 carbons, right? We put in our equal sign. This side has to equal this side. So 4 carbons, carbon's good. Hydrogens, 10. 2 times 5. That'll give me 10. That'll balance that out. Everything is awesome so far, right? Here's our problem. Oxygen. I've got 2. Over here, I can already see I'm going to have 8 here and another 5 there. That's 13, right? That's a problem. Because no matter what number I put in this position, I've got 2 oxygens. So I've got to make this 13. Well, I can't do that. I know that regardless of whatever number here, it's going to be an even amount of oxygens. This 5 is not ever going to make it even. 2 times something will be even, but 5 is not even. So what I have to end up doing, it's kind of a weird thing, is I have to go and double everything. So now I have 2 of these. I'll get rid of that and put 8 there, and get rid of that and put 10 there. Seems weird, but it's going to work. Watch. I'll erase this, and we'll put in the 8 and the 10. All right. Get rid of that. And we'll see how it works out. All right, so now if I double it, 2 times 4, which is 8. I'll put my 8 here. Right? 2 times 4 is 8 carbons, 8 carbons. 2 times 10 is 20 hydrogens. Here it's 2 times 10. 20 hydrogens out because 20 went in. 2 times 10. That 10 is an even number. The 5 was odd, which kind of messed us up over here. The 10 is even. 8 times 2 is even. This is going to work out because whatever I put here, it's going to be an even number. So 8 times 2 is 16 oxygens. And then we have 10 times 1, which is 10 oxygens. That makes a total of 26 O's over here. 2 times 13. Seems kind of weird, but that's the way that one works. So now everything is balanced. Combustion reactions will do this to you once in a while. All right. One last quick example. This is the one I'm always amazed at, this one. But what we're going to do here is we're going to take some HCl, hydrochloric acid, add it to some NaOH, sodium hydroxide, a base, and we're going to get H2O and NaCl. That N is a little sloppy, but it's late, so what can you do? You'll just have to live with that. Anyway, this is a neutralization reaction, one of the type of double displacements you learn about in grade 10. So we've got HCl, hydrochloric acid, sodium hydroxide, acid, base. Of course, acid and base neutralize to form water and a salt. The NaCl is our salt. Anyway, let's balance this. One H there, plus there's an H here. So there's two H's going in. Well, that's fine because there's two H's coming out, right? As we know, that yield arrow kind of acts as our equal sign. This side is equal to this side. So two H's. Hydrogen is fine. Chlorine, I've got one chlorine here and one chlorine there. Chlorine is fine. Sodium, one here, one here. Sodium's fine. And oxygen, 1 and 1. Sometimes if you do your formulas properly, it just works out that the proper formulas will balance themselves out already. There's no need for any coefficients here. We don't need them at all. But you'll be surprised at how many students will still add one in there. Don't be that student. Not every equation needs coefficients to balance it. Lots will, but every so often you come across one that doesn't. So if you come across that, I always get students that feel the need, oh my God, it's balancing, and they put all twos in here, or they'll throw in numbers just cause, right? So if you come across something that's already balanced, just leave it. It's not breaking the law. Leave it alone. Anyway, hope that made it crystal clear. There is a worksheet. I attached a Word document to our D2L site on balancing equations. Give that a go using the information that you already knew and the information from this. Anyway, take care and hopefully see you soon. Hope you enjoyed the video. Bye-bye.